This is going to be a solution and answer key for this graded assignment in Algebra 2. First problem, 3s equals 45. This is a simple one-step problem. Both sides need to be divided by 3. 45 divided by 3 is 15, and so s is equal to 15. Okay, the next problem is also a single-step problem, although if you want to break it up into pieces, you could do it in multiple steps. Here's what I mean. The problem with m is that it's being multiplied by 2/3, which means what you ought to do is divide both sides by 2/3, aka multiply both sides by 3/2. This is going to cancel out the 3's and the 2's. That is simply the multiplicative inverse. And if you do that, you've got m by itself and then 3/4. Now, like I said, you can break it into two pieces if you're not comfortable with fractions. Just remember that 2/3 m is the same thing as 2m divided by 3. So you could multiply both sides by 3 and then divide both sides by 2, but that's exactly what multiplying by 3/2 is. Either way, we've got an answer. M is 3/4. Okay, next up, another one-step problem, this time involving a decimal, 0.2b. Sounds depressing. 0.2b equals 10. Okay, dividing both sides by 0.2. If you're not sure how to do this, I'm guessing a calculator would give it to you, but you might also know that 0.2 is 1/5. So dividing by 1/5 is the same thing as multiplying by 5. The answer is 50. Okay, we're finally moving into two-step problems. 120 minus 3/4 y. We still have to deal with fractions here. Equals 60. Now, personally, I'm not a fan of negative numbers, so my first move is actually to add 3/4 y to both sides. And that's going to give me 120 equals 60 plus 3/4 y. Okay, now I can get all the numbers onto the same side, so I'm going to subtract 60 from both sides. 120 minus 60 is 60, and so that's 3/4 y. Okay, so now to get y by itself, I'll multiply both sides by the reciprocal of 3/4, which is 4/3. And so this is going to be 4 times 60 is 240. 240 divided by 3 is 80. Or if you prefer, 60 is 3/4 y. Well, what is 60 3/4 of? 20, 20, 20, that's 60. 20, that's 80. Okay, so y is 80. That's a deep philosophical question. Why is 80? And then the last problem in this set, 4n plus 20. There's a variable on both sides. This is always a classic difficult algebra problem. Equals 53 minus 2n. I'm not sure, that actually might be in the glare, so I'm going to rewrite that down here. I know there's some glare from the projector, and I might have just run into it. Okay, so for this one, I'm going to consolidate the variables. I'm going to add 2n to both sides. So now I've got 6 n's on the left and no n's on the right. I can go ahead and subtract 20 from both sides. Now it's nothing but n's on the left, 6 of them, and then there is 33 on the right. Okay, well, the only thing left to do is to divide both sides by 6. And so n is now by itself. Now 33/6, you could get a decimal out of it. I'm going to reduce the fraction. 33 and 6 are both divisible by 3. That would be 11/2, which is a perfectly sensible answer. However, if you are calculator dependent or a decimal person, you might better know this as 5.5. However, I'm a fraction guy, so that's the answer I'm going to write. N is equal to 11 halves. But since most of you probably wrote 5.5, I'll just put it second. Okay, so that is all of the solutions to the first group. Second group, we are solving each equation for a specified variable. Okay, so in the first one, A is 3b minus c, and we are solving this for b. To isolate this, first thing we're going to need to do is move that c over here. So we've got a plus c equals 3b, and now we can just divide both sides by 3. And actually, that's it right there. It's just a plus c over 3, because b is now by itself. B is equal to a plus c over 3. I know it may not look finished when this is what you're expecting a math solution to look like, but that is a legitimate algebraic expression. Okay, next up, h equals 12g minus 1, solving for g. It's basically the exact same steps as before. I have to add something to both sides, and then divide both sides by something. And that would be it right there, because those 12s cancel out. G is just h plus 1 over 12. Okay, next up. This one is a little bit more complicated because there is an x on both sides. Just like in life, sometimes x causes the problem. Equals x plus 7. Okay, so in order to get x by itself, I need all of my x's to be on the same side, and the simplest move for that would be to subtract x from both sides. Okay, so now I've got 2xy minus x, and this is equal to 7. Okay, now this move, okay, is going to be based on the distributive property, which, if you recall, looks like this. Hopefully that's not in the glare. A times b plus c equals a times b plus a times c. If you've got the same factor in both terms of a sum, you can simply remove it. And I do have the same term in both terms of a sum, so I'm going to remove that. X of everything but the x here, 2y, and then everything but the x here. That would be 1. Okay? And if you don't believe me, distribute this back in, and you'll see that's what comes out. Well, now we are trying to get x by itself. The only thing left to do is to divide both sides by 2y minus 1. And there we have it. It is 7 over 2y minus 1. Okay, well, 22. We are solving for j. The problem is 3 of 2j minus k equals 108, solving for j. So the first thing I would do is divide both sides by 3. So let me show the work there. Dividing both sides by 3, I've got 2j minus k, and then 108 minus 3. I know that that's 9 times 12. So if I divide that by 3, that would be the same thing as 3 times 12, which is 36. Is that right? 3 times 6 is 18, so it ends in an 8. Yeah, that's right. Okay, so if I'm solving for j, I need to get j by itself. I'm going to add k to both sides. That's going to give me 2j equals 36 plus k. And the last, almost last step, is to divide both sides by 2. The reason why I say it's almost the last step is because this can be simplified. 36 plus k over 2 is the same thing as 36 over 2 plus k over 2. And 36 over 2 can be reduced. That's 18. So if we turn this into 18, then the final... I changed y into j a second ago. That's just great. I'm too far into this. I'm not starting over. Anyway, so j is going to be 18 plus half of k. Okay, finally to the last problem. M over n plus 5m equals 20, solving for m. Okay, so this fraction might look a little intimidating, but don't worry about it. As soon as I rewrite this, I think you'll see this is no big deal. M over n is the same thing as m divided by m. I'm sorry, m divided by n, but it's also the same thing as 1/n of m. Now, if you will notice, this is a number of m's, and this is a number of m's, which means we are talking about this rule again. When you have some number of a's and some number of a's, you can take out that common factor, and there's your sum. So in this case, m would be my a here, which means I can take it out, and whatever goes here is however many m's there were added up. 1/n and also 5. So finally, to get m by itself, I would divide both sides by whatever is multiplying m. And that cannot be simplified. Actually, you might be tempted to think 20 over 5, that's equal to 4, but when the sum is in the denominator, you can't break that apart like you could. Just because this is the last problem, let me give you a quick little demonstration as to why that is after I write the answer. M is equal to 20 over 1 over n plus 5. I hope that shows up in the video. It is kind of small. Let me give you a demonstration of why that doesn't work with the simplification. Okay, so we are all familiar with, say, like, 12 over 6 equals 2, right? Okay, well, think about it like this. 12 is like 10 plus 2, right? So that means this must also equal 2. This one maybe isn't the easiest. Let me try this one. 9 plus 3 over 6. 9 plus 3 is 12, so this would be the same thing as 9/6 plus 3/6. 9 over 6 is 1.5. It reduces to 3/2. And 3 over 6 is 1/2, which means that this whole thing is 1.5 plus 1/2. Of course, that's equal to 2. So when you have a sum in the numerator, you can reduce that because of this property that you can split up the fraction. All right, now let's try that in reverse, okay? If I were to take 6 over 2, I'm sorry, 6 over 12, we know that that is 1/2. Okay, now let's try that like this. 6 over, again, 9 plus 3. All right, well, this is not the same thing as 6 over 9 plus 6 over 3. It absolutely just cannot be. And why this is obvious is that this is 2/3, which is bigger than 1/2, and this is just straight up 2, which is greater than 1/2. You can't simplify things when the sum is in the denominator, right? You cannot isolate in the case of this one, the 5 from the 1 over n. So you can't reduce 20 over 5 into 4 because this doesn't work. Anyway, hopefully that last little bit was helpful to anyone who had that issue. And we're all done with this solution.